Okay, today we're going to do some problems with chords of circles. Remember, a chord is a segment with endpoints on a circle. A circle is all the points equidistant from a given point on a plane. All right, if BC is the perpendicular bisector of FG, then what is equal to what? All right, BC is the perpendicular bisector. BC is perpendicular bisector of FG. Cuts it into two congruent parts. Then what is equal to what? Well, if it cuts it into two congruent parts, then FC would be equal to CG. And what would the measure of angle BCF be? Well, it's a perpendicular bisector, so it's perpendicular, and it would be 90 degrees. Also, BC would contain the blank of the circle. Well, that was one of our theorems in the previous video that would prove this. It would be the center of the circle. If DE is equal to FG, if DE is equal to FG, well, those are two chords. If DE is equal to FG, then what do we know? Well, if chords are congruent, then we know that their distance from the center of the circle is congruent. So then BH would be equal to BC. The distance from the center to the chords would be congruent if the chords are congruent. Also, you know that if the chords are congruent, their arcs are congruent. So arc DE would be congruent to arc FG. You could also do the major arcs, but there's not enough room for our answer. All right, number 3, if BC is perpendicular to GF, BC is perpendicular to GF, then what do we know? All right, well, if it's perpendicular, we know that the angle it makes is 90 degrees. So the measure of angle BCG or BCF would equal 90 degrees. Since BC is also contains the center, we also know that CF would be equal to CG, because if a segment is perpendicular to a chord and contains the center, then it bisects the chord. So those two segments would be congruent. All right, lastly on this page, if BC is perpendicular to FG, if BC is perpendicular to FG, and BH is perpendicular to DE, and BH is congruent to BC, then what do we know? All right, if two chords are the same distance away from the center of a circle, then these two chords must be congruent. So DE, segment DE, would be congruent to segment FG. All right, next slide. Given that AH equals 3, PG equals 4, and EF is equal to AB. Right? Let's find, first let's find Y. All right, well, this segment here, PH, contains the center and it's perpendicular. So it bisects AB, and it would also bisect the minor arcs. So if arc CB is 42 degrees, then arc AC would be 42 degrees also, so Y would be 42. Same thing. Now we have to find X. Well, we use the fact that EF is congruent to AB. If EF is congruent to AB, is equal to AB, then we know the chords are the same length. So if PG is perpendicular from the center, then we know it's going to be bisecting EF. And it would also bisect the minor arcs, excuse me. So if this arc EF is congruent to arc AB, then when you bisect them, they would be congruent to each other, the bisected parts. So X would be the same as Y, 42 degrees. pH. How long would pH be? Well, again, since the chords are congruent, we know that the chords are the same distance from the center. If EF is 4 away from the center, then AB would be 4 away from the center, so pH would be 4. Find the radius of circle P. Okay, find a radius. Well, if I notice right here, I have 3 and 4, and I have a right angle. So let's draw the radius right here. And magically, you should recognize this right away as one of our triples. 3, 4, 5, Pythagorean triple. So what would the radius be? PA would be 5. Find EF. Well, we know that EF is equal to AB. And we know that AB has been bisected. We know AB has been bisected. So if AH is 3, this is 3, so AB would be 6. So if AB equals 6, then EF would equal 6. Following it says find the measure of angle EPF. Find the measure of angle EPF. Well, that angle's not in there, so let's draw it first off. EPF. To find this angle, that's a central angle. And we know that central angles are equal to their arcs. So if X was 42 degrees, then arc DF is 42 degrees. And we know that that minor arc EF has been bisected, so ED, arc ED, is 42 degrees. So using the arc addition postulate, we would say that arc EF is 84 degrees. All right, you're going to be given some problems similar to this. If you have any questions, don't be afraid to ask.